Now let's go for the miscellaneous types for the combination. Total number of combination. Now in the total number of combination we are going with type 1. Type 1 we are having, it is, now type 1 is to find total number of combinations of n dissimilar things taking any number of them at a time. Is it clear? To find total number of combinations of n dissimilar things taking any number of them at a time, then what are the possibilities? Now here we are having two types of possibilities. Now possibility number 1 we are discussing with as a case 1. Now in the case 1 what we are going to write, that is when all things are different. When all things are different. So this is case 1. Now basically what it states, now what I am just going to explain you with the definition part, written part, and then with the example. Okay. So now in this case each thing may be disposed in, each thing may be in two ways. Now what are the two ways? The two ways are, it may either be selected or rejected. Now how this is possible? Let me explain you this simple sentence. Now for example, in an unit class test you are given 5 questions. Now you can, what you can do? You can do all the questions, you can do few questions, or you can't do even a single question. So that is what, it may either be selected, okay, or rejected. Now suppose there is only one question to solve it, either you can solve it or you can't solve it. So when you can solve it, that is selected, when you can't solve it, that is rejected. Okay. Now therefore the total number of ways of disposing of all the things is equal to 2 times 2 times 2 times, like this, up to n times. Now what 2 times means? Either rejected or selected. Okay, either we can do it or we can't do it. Okay. So now this further, this what we can write it? We can write it 2 raised to power n times. Now but also there is a chance that all the things are rejected. Okay. Now hence the total number of ways in which one or more things can be taken is equal to 2 raised to power n minus 1. Okay. So this is what? This is the basic formula for case 1. 2 raised to power n minus 1. And same thing, in the next chapter we are going with the binomial theorems. In there we will be discussing some binomial coefficients. There also you will be getting the same thing. Okay. So now for the combination part, now what this holds, what it sends. Now the sense seems to be, now since the number of things to be selected can be 1 or 2 or up to n, therefore required number of ways is equal to NC1, NC2, NC3, NCn, and this is given by 2 raised to power n minus 1. Okay. So both the things I have just explained you. Now I am going to give you an example for it.